Here's yet another solution video. This time it is for your more Newton's second law practice, where we have 9 diagrams just utilizing Newton's second law to identify net forces, accelerations, and masses of objects. So let's go ahead and get started. Number 1. Here we see what appears to be a coffee filter falling through the air. We have air resistance of 0.1 newtons pulling up, force due to gravity at 0.1 newtons pulling down. So these forces, your net force here, is equal and opposite. So we have 0.1 and 0.1. So we find the sum of the forces. We would do 0.1 newtons minus 0.1 newtons to get a sum of 0 newtons. If we have no net force, it means we have no acceleration. To find the mass of this object, it is using your force due to gravity, Fg equals mg, where g is always 10. And in this case, we can call it negative 10 because that force due to gravity is negative 0.1. So if we do negative 0.1 divided by negative 10, we will get a mass of 0.01 kilograms. Number 2, for some reason an elephant is falling through the air. The elephant has a mass of 10,000 kilograms. So we take 10,000 kilograms, multiply it by the force due to gravity, which is 10 newtons per kilogram. We will get a force due to gravity of 100,000 newtons. 100,000 newtons. So now we know our force due to gravity. We know that our acceleration is 8 meters per second down. So in order to find this net force, we need the sum of the forces in y. The sum of the forces in y to equal our mass of 10,000 kilograms. And we'll multiply that by 8 meters per second down. And because it's down, we can call that negative, along with that force due to gravity. So when we take 10,000 kilograms, multiply it by negative 8 meters per second, we will get a sum of our forces of negative 80,000. So if we have negative 80,000 newtons and our force due to gravity is negative 100,000 newtons, that means that our air resistance will then come out to be a positive 20,000 newtons. Letter C. Here we're given a mass of 800 kilograms. So again, to find force due to gravity, it is mass times force due to gravity. That F sub g equals mg, where g is always 10. So our force due to gravity is 8,000 newtons, and it is going down, so it is negative. Now here we see an upward acceleration. So when we find the sum of our forces, we want the sum of our forces in y, and that will equal our mass of 800 kilograms times our acceleration of 6 meters per second, which would give us the sum of our forces in y will then equal 800 times 6, which is 4,800 newtons up. So the sum of our forces is then 4,800 newtons. And that number is positive. So we get the sum of our forces. We know our down force is negative 8,000. We don't know what that up force is. So here we want 4,800 equals our up, and then minus, so we're going to add our down, which is subtracting 8,000. So when we add 8,000 newtons to the other side, we see that the air resistance is then 12,800 newtons. Letter D. Letter D, the sum of our forces in y is 0, so we have no acceleration in y. However, to find our mass, we will still use that force due to gravity. So here, our force due to gravity is 10,000 newtons. And we will divide that by 10 because that is the gravitational field strength, that acceleration due to gravity, which will give us a mass of 1,000 kilograms. 1,000 kilograms is our mass here. The sum of our forces, in y it's 0 because we're equal and opposite. However, in x, we do not have an applied force, we just have friction pulling back. And because it's pulling to the left, our force is negative 9,000 newtons. Negative 9,000. In order to find the acceleration, we use Newton's second law, which is the sum of our forces equals mass times acceleration. Here we know a mass and we know a sum of our forces. So to find the acceleration is then force over mass. Our force is negative 9,000 newtons and our mass is 1,000 kilograms. So we have an acceleration of negative 9 meters per second per second. Letter E. Letter E, we have a football that has a mass of 0.5 kilograms. So to find the force due to gravity, we would take 0.5 kilograms, multiply it by 10 newtons per kilogram, to then find that our force due to gravity is 5 newtons. And because this object is accelerating to the right, as is denoted in the question, that means that the normal force must also be 5 newtons. This object is accelerating to the right. We know that it has a net force of 124 newtons. There is no friction acting against it, so that will be our force applied then as well. And now using Newton's second law of force equals mass times acceleration, we know our force is 124 newtons. We can divide that by the mass of 0.5 kilograms to then get a very, very large acceleration of 248 meters per second per second. So here we get a guy pushing a car with an acceleration of 1.5 meters per second to the right. We are given a force due to gravity of 9,000 newtons. So again, using force of gravity equals mg, we will find our mass, m, by dividing 9,000 newtons by 10 newtons per kilogram to get a mass of 900 kilograms. So this object is accelerating to the right, and according to the force diagram that's drawn, there is no friction acting to the left. It seems strange, but that's how the force diagram is drawn. So with no friction to the left, that means that the sum of the forces in x will then be the applied force. So here we know a mass and we know an acceleration. So using Newton's second law of force equals mass times acceleration, we see that we have 900 kilograms for a mass, and we can multiply that by 1.5 meters per second to the right to get a sum of our forces of 1,350 newtons, which is also the applied force. Working down to G. G, we're given a mass of 15 kilograms. So again, force due to gravity, F sub G, equals mass times your gravitational field strength of 10. So here we have 15 kilograms times 10 newtons per kilogram to get a force due to gravity of 150 newtons. The question says that we're accelerating to the right, which means that the normal force will also be 150 newtons to balance it out. Again, there's no force acting on this cart to the left. It is just an applied force to the right. So it is accelerating to the right. We know that the sum of the forces in x will then be the mass, 15 kilograms, multiplied by the acceleration of 0.5 meters per second to the right, to give a sum of the forces of 7.5 newtons, which is also the applied force. H, we have a sledder. Friction acting at 100 newtons. Force due to gravity and normal force are equal and opposite at 600 newtons. So we know that the sum of our forces in y becomes 0. So there's no acceleration in y. We know that the sum of the forces in x will be negative 100 newtons. We know this because there's no applied force going to the right. It is just the leftward friction force. To find the mass, we're given our force due to gravity of 600 newtons. However, in order to find this, we have 600 newtons. We want to divide that by the gravitational field strength of 10 newtons per kilogram, and we will get a mass of 60 kilograms. So now we have a force and we have a mass, so we can take negative 100 newtons, divide that by 60 kilograms to find that our acceleration, and I'll write it down below, the acceleration is negative 1.67 meters per second, and it is to the left. And last one, letter L, we have a mass of 2,000 kilograms. So right away, 2,000 kilograms, multiply that by 10 newtons per kilogram to get a force due to gravity of 20,000 newtons. And because it's down, we can call it negative. Our normal force is then 20,000 newtons. We know that because there's no acceleration up or down. The acceleration is happening to the right. So now we know a mass. We know an acceleration, so we want to find our net force. So the sum of the forces in x, to be the mass times the acceleration. We have a mass of 2,000 kilograms, an acceleration of 2 meters per second, so that the sum of our forces in x becomes 4,000 newtons. So we have 4,000 newtons as the sum of our forces. The applied force is 14,000, which means that if the sum is 4,000 greater, that means that the sum is 4,000 newtons. Friction must be pulling back at negative 10,000 newtons, as the sum is 4,000.